In Chapter 9, we're going to start talking about sequences and series. 9.1, we're just going to talk about sequences. Sequences are basically just a list of values. So we're going to list these things out. When we talk about series, which we'll get into next time, that's when we take those individual values and add them together. Alright, so a sequence is just a list. It's commonly written in subscript notation, which means we refer to the nth term as a to the n. So the first term is a to the a sub 1, a sub 2, a sub 3 is the third term, and so on. So a sub n is the nth term. And then the whole sequence, we use these brackets to denote the sequence itself. So just some examples here. If we want to write the first 5 terms excuse me, of this sequence, 3 to the n, then we have 3 to the first, 3 to the second, 3 to the third, 3 to the fourth, and 3 to the fifth. Right, we could simplify those. We have 3, 9, 27. What are we looking at here? 3 to the fourth is going to give us an 81, and then times another 3 will give us 243. Alright, so there's the first 5 terms of this sequence, 3 to the n. We could also list the first 5 terms of this sequence here. We have 2 over n factorial. Alright, so the first term is going to be 2 over 1 factorial. The second is going to be 2 over 2 factorial. 2 over 3 factorial is the third term. 2 over 4 factorial. 2 over 5 factorial. Alright, and remember that factorial, so this last term really would be 2 over 5 times 4 times 3 times 2 times 1. Alright, so that's really 2 over, let's see, we have 60, 120. So that last term, a sub 5, would be 1 over 60. So we also might be given the sequence. We might be shown the first several terms in a sequence and want to write it in write that sequence in terms of n. So if we're given 3, 8, 13, 18, we might be given we could write that as 5n minus 2. A sub n is 5n minus 2. Right? We might also see that we kind of see it here, but we're adding 5 each time we go to the next term. Right? So this is an arithmetic sequence, and so another way that we could write it is we could write it here where a sub n is equal to the first term plus n minus 1 times the difference, the d. Right? Here the first term is 3 and the difference is 5. So we could write it as 3 plus n minus 1 times 5, which gives us the same thing as we kind of saw when we just sort of looked at it as 5n minus 2. Right? This next sequence, we see that the sign alternates, right? And that's kind of a dead giveaway that we're going to have a negative number, either -1 or some other negative value inside the parentheses that's being raised to the power. So if we have -3 squared, if we have n equals 3, then we're going to have -3 squared. That's going to be positive. If we have -3 to the third, so if it's 4 minus 1 here, then we're going to get a negative, and that's going to alternate the terms for us. Right? This is a geometric series. We multiply by a common ratio every time. So each time we multiply by a -3, -3, -3. And those in general take the form a sub n equals the first term, a sub 1, times that r, the common ratio, to the n minus 1. Notice that both of these use this n minus 1, and the reason for that is the first term was already here. So when we multiply by our first 3, so we have 5, that's our first term. Here we're multiplying by a negative 3 to the first power. But this is the second term, right? This is a sub 2. There. So that's the n. So we really only want to multiply by 1 negative 3. So we have to subtract 1 from the n to give the proper exponent on that negative 3. And we do the same thing up here with the 5. The very first time we add 5, we're only adding 1 5 to get the 8, but it's the second term, so it's 2 minus 1 gives us that 5 that we're adding. Here we have 4, 10, 28, 82. So when we look at this, we kind of think, well, if we just thought about this as 1 less for each of these terms, it would be 3, 9, 27, 81, which are all powers of 3. So we might be able to discern that pattern out of there, 3 to the n plus 1. And then the last one we'll look at on this page is 1 over 4, 3 over 7, 5 tenths, 7 thirteenths, 9 sixteenths. So we kind of have to look at these individually and look at the pattern in the denominator and then look at the pattern in the numerator. All right, they're not necessarily related to each other, but if we go, this is, for me it helps to kind of think of this as the first term, the second term. We have a, really I should use this, a sub 1, a sub 2, a sub 3, a sub 4, a sub 5. So when I look at this, I'm thinking about 5. Here I'm thinking about 4. So how can I go from a 4 to a 13? Well, I could triple it and then add 1. Or from the 5 to the 16, I could triple it and add 2. And up here is the same one. I have a sub 1 is 1, a sub 2 is 3. So you can see that I'm adding 2 each time. Right? So that gives me, I'm going to have a factor of 2 times my n. And these are 1 less than just doubling the n. If I doubled this 2, I would get a 4. If I doubled this, I would get a 6. If I doubled this, I would get an 8. So we kind of look at that and look at the numerator and denominator individually.